Today, we will talk about food safety and food security. What do you know about food safety and food security? Food safety and food security are used interchangeably and are thus confused. Food safety refers to protecting food from biological and other sources of contamination, whereas food security refers to access to food and issues of hunger. Food supplies are generally maintained at high levels of safety, protected from accidental or deliberate contamination, so that citizens seldom give much thought to this food supplies. Food safety becomes a public issue except on occasions when outbreaks of foodborne illness or malicious threats make headline news. Food safety and local rules and regulations about food safety, its surveillance and response to these disasters resulting from either natural or human causes, as well as the safety education of both sides and the general public. Safety and quality of food supply are a complex system. Department of Agriculture and the Food and Drug Administration within the Department of Health and Human Services have primary responsibility for food safety. Food supply is among the safest in the world. Foodborne illness is recognized as a significant public health problem. Foodborne pathogens sicken many people in the world every year. The Centers for Disease Control and Prevention attributes 76 million illnesses, 325,000 hospitalizations, and 5,000 deaths to foodborne pathogens annually. These numbers may underestimate the magnitude of the problem, as many people do not seek medical help for foodborne illness. Thus, occurrences are not officially reported. That's why these estimates and numbers may be underestimated. Non-pathogens are estimated to cause one-third of deaths, whereas the remaining two-thirds are caused by unknown agents. Most vulnerable group to the foodborne diseases are children, pregnant women, elder people, and people who are immune compromised. A large population are HIV positive. They are also a vulnerable population. The most common foodborne pathogens include norovirus. Norovirus is the leading cause of diarrhea. Any food can be contaminated with norovirus if handled by someone who is infected with this virus. Campylobacter is the most common bacterial cause of diarrhea, resulting in 1 to 6 million illnesses each year. Raw and undercooked meat and poultry Raw milk and untreated water are the main sources of this infection. Clostridium botulinum produces a toxin which causes botulism, a life-threatening illness that can prevent the breathing muscles from moving air in and out of the lungs. Home prepared foods and herbal oils. Honey should not be fed to the children less than 12 months old. E. coli can produce deadly toxins, has emerged as an important cause of foodborne illnesses, causes the 20,000 to 70,000 cases of foodborne illnesses each year. Meat, produce, and raw milk are the sources of the E. coli. Listeria monocytogenes causes listeriosis, a serious disease for pregnant women, newborn and adults with a weakened immune system. Sources of the pathogen include unpasteurized dairy product and soft cheeses, raw and undercooked meat, poultry, seafood, as well as soil and water. Salmonella is also the most common cause of foodborne deaths, responsible for 2 to 4 million cases of foodborne illness annually. Sources of infection include raw and undercooked eggs, undercooked poultry, meat, dairy products, fruits and vegetables. Streptococcus aureus is a bacterium that produces a toxin that causes vomiting soon after eating contaminated food. The main sources of this bacterium is protein sources such as cooked products, salads, bakery products, and dairy products. Shigella virus causes as estimated 3 lakhs cases of diarrheal illness annually. Shigella may be passed from persons to person due to poor hygiene. Salads, milk, dairy products, and unclean water are main sources of this Shigella virus. Toxoplasma gondii are parasites that causes toxoplasmosis, which is a disease that can produce central nervous system disorders, mental retardation, visual impairment in children. Pregnant women and people with weakened immune system are at higher risk. Meat are the main sources of this parasite. Vibrio vulnificus. This causes the gastroenteritis or a syndrome known as primary septicemia. People with liver diseases are especially at high risk. Raw and undercooked seafoods are the sources. Federal, state, and local authorities play complementary and interdependent roles in regulating food and food processing facilities. The responsibility for assuring the safety, wholesomeness, and proper labeling of all food lies with two departments, the USDA and HHS, and one independent agency, the Environmental Protection Agency. The Food Safety and Inspection Service of the USDA ensures that meat, poultry, eggs, poultry-based foods, and some egg-based products are safe, wholesome, and accurately labeled. The FDA, an agency within HHS, is charged with protecting consumers from impure, unsafe, and fraudulently labeled domestic and imported foods, other than those regulated by the FSIS. It is also responsible for ensuring that all animal drugs and feeds produce no risk to human health when used in livestock. No food or feed item may be marked legally if it contains a food additive or drug not permitted by the FDA. The CDC and other agencies within HHS track foodborne illness outbreak. The EPA's mission include protecting public health and the environment from risk posed by pesticides. It establishes tolerance for pesticide residues in foods and ensures the safety of drinking water. All these agencies use existing food safety and environmental laws to also regulate plant, animals, and foods developed through biotechnology. In 2005, the food safety budgets requested for the FSIS and the FDA were $824 million. These allowances support for food safety and counterterrorism initiatives in the FDA, as well as funds for the USDA's Office of Food Security and Emergency that coordinate the development of infrastructure to prevent, prepare, and respond to an intentional attack on the food supply. Food and Drug Administration is a regulatory authority for food is conferred on the FDA, the Federal Import Milk Act, the FFDA of 1938 as amended, the Public Health Service Act, the Fair Packaging and Labeling Act of 1966, the Infant Formula Act of 1980 as amended, the Nutrition Labeling and Education Act of 1990, and the Dietary Supplement Health Education Act of 1994. Only after food safety had been addressed did legislation address food packaging and labeling. Food labeling is mandated under two federal agencies, FDA and the FSIS. The FDA is responsible for food labeling regulations on all food products, except meat and poultry items, which are regulated under the FSIS. The FFDCA prohibits the entry into interstate commerce of adulterated or misbranded foods. Under this authority, the FDA has established guidance and regulatory requirements for manufacturers to ensure that food is safe and unadulterated. The Fair Packaging and Labeling Act was passed to help consumers make informed decisions about the products they were purchasing and established general and specific principles for food labeling. The Nutrition Labeling and Education Act, passed in 99th Amendment the FFDCA by the United States, allowing regulations to be expressed on food labels. This act mandated nutrition labeling on most packaged food products and instructed the FDA to control and set standards for the content and format of the nutrition label. In passing the TSHEA in 1994, United States amended the FFDCA to include several provisions exempting dietary supplements, and their dietary ingredients from the pre-market safety evaluation required of other new food ingredients or for new uses of old food ingredients. Dietary supplements must still meet the requirement of other safety provisions. Genetically modified foods, through extremely controversial, are similarly exempt from information labeling in the genetic modification transfers specific traits or genes from one organism to a different plant or animal. Desirable traits include pesticide and herbicide resistance, improved hardiness, and increased content of specific nutrients. A gene is a specific sequence of bases that creates proteins that confer a trait to a plant or animal that the vast majority of genes do not code for a unique protein, as was previously believed, undermines the foundations of genetic engineering of food crops. Foreign genes have the potential to create unintended proteins with unpredictable effects on the ecosystem and human health. Genes are inserted into DNA using either a gene gun or bacterial vectors. The gene gun fires microscopic pellets coated with DNA into a host cell, and some of this DNA coating is left within the cell as the pellet passes through an imprecise and unstable form of insertion, rather than precise, predictable, and safe method its advocates claim. Mutations could occur during insertion, accidentally affecting the level of toxins a plant produces or otherwise impacting a plant's normal metabolism. Key experiments to assess both the environment, risks, and benefits of gene insertion have not been undertaken. Despite these concerns, genetic engineering has enjoyed considerable success. 70% of food on the supermarket shelves have genetic modified ingredients. Many of the anticipated benefits, decreased input dependence, increased nutritional quality, and feeding hunger, have not materialized. The Genetic Engineering Action Network recommends four major areas of reforms, which include prior informed choice, which is a labeling rhyme must be created. Assessment include better oversight and raising and apportioning resources for an effective system. Protection include ending exposure of farmers and consumers to unchecked industry power. Liability includes accountability for harm caused to human and the environment. There are some arguments for and against the pursuit of genetic modification. Presents a timeline that encompasses labeling related issues. For and against genetically modified organisms claims for reduced pesticide use, improve crop yield, reduces the famine due to crop failure, improves weed control and reducing the fuel use and soil erosions, enhances nutritional quality, for example in rice enhanced with vitamin A, eliminates allergens, for example P34 gene in the soy, incorporates vaccines that can eliminate disease, expands agriculture to inhospitable land. Argument against introduces new allergens into the food supply, antibiotic resistance to marker genes, reduces the nutrient quality such as loss of phytoestrogens, reduces usefulness of Bt as an insecticide, and harms non-target organisms, introducing superweeds through genes flow from herbicides, resistant crops to wild relatives, impacts animals such as Medica fish, where genetic manipulation for size affected the reproductive fitness. Possible long-term side effects of ingesting genetically modified foods: lack of the promised yield in genetically modified crops, possibly from conflict with other selection criteria, reduces the non-edible fiber portions of grain, reducing the availability of fiber for weaving, impacting the local handicrafts, contaminants due to cross-pollination, lack of adequate testing for environmental and human impact before release. Legal system has on the development of food policies related to genetically modified food plants has no legal food policy. A genetic engineer employed by General Electric developed a genetically modified bacterium capable of breaking down crude oil. The microorganism had the potential to be used to control oil spills. The first order of business was to apply for a patent for the bacterium. The patent was initially rejected on the basis that law had never extended patents to living things. The Supreme Court eventually held that the scientist was entitled to a patent on the microorganisms because it was synthetic, did not occur naturally in any other bacterium, and qualified as a manufacturer or composition of matter. In other words, patentable subject matter. The 1918 ruling made it possible for Stanford University to receive the patent it had applied for in November 1974 to cover the technology they developed for DNA. In 1973, Cohen, his lab assistant, and perfected techniques to cut and paste DNA using restriction enzymes and ligases and reproduce the new DNA in bacteria. The patent covered not only the processes developed in the experiment but also the cells containing the new DNA. The patent, which may be the most successful patent in university licensing, generated $139 million in royalties in the first 15 years that it was held. The Supreme Court decisions spurred a boom for the creation of dedicated biotechnology companions in the 4 year period 1980 to 1984. Funding surged for companies dedicated to biotechnology. The legal precedent set in was extended by the California Supreme Court in 1990 into the date-leading case. On the issue of gene patenting, a leukemia patient at the medical center sued his physician, who, after excising spleen and collecting numerous additional tissue samples from him over the years following the surgery, patenting a cell line developed entirely from tissues. His suit focused on the appropriation of property rights over his body parts without his informed consent, although the court agreed that the patient had a cause of action against the doctor's breach of his duty to receive the patient's informed consent. The patient had no rights over the tissue samples voluntarily given. These two cases taken together have tremendous implications for property rights over genetic materials. In light of these rulings, biotechnology companies can confidently develop patentable technologies relating to cell genetic material from animal and plant sources, regardless of how the original tissues were obtained. Over the last 2 decades, major agrochemical companies have been racing to buy up seed companies and patent their seeds. The market share strategy, combined with the careful regulatory strategies, were part of a larger plan to transform the food industry and make genetically modified food for more acceptable to the public. Although the Center for Food Safety estimates that as much as 60% of processed foods on supermarket shelves contain genetically modified ingredients, the revenue derived from the planting of genetically modified crops are actually falling. This is due to the consumer backlash against genetically modified foods, resulting from media coverage of inconsistencies in regulatory practices and safety testing, as well as highly publicized trials concerning consumers' right to know which food contained genetically modified ingredients. Prior to 1980s, infant formula was regulated under 21 Code of Federal Regulation. This regulation specified minimum levels of certain nutrients for infant formulas, including protein, fat, and some vitamins and minerals, but a level of chloride was not specified. In 1978, a major manufacturer of infant formula reformulated two of its soy products by discontinuing the addition of salt. This resulted in infant formula products containing an inadequate amount of chloride, an essential nutrient for infant growth and development. By mid-1979, a cluster of infants have been diagnosed with hypochloremic metabolic alkalosis, a syndrome associated with chloride deficiency, which was eventually associated with prolonged and exclusive use of the chloride-deficient soy formulas. Chloride deficiency can result in growth retardation or manifest central nervous system effects such as cerebral dysfunction or impaired cognitive functions. This outbreak highlights two critical important elements of public health practices. First, developing and using appropriate case definitions for both surveillance and for the investigation of outbreaks of both infectious and non-infectious origin enables local and state health departments and the Public Health Service to respond rapidly. Second, nutritionists play a significant role in identifying and resolving public health emergencies. After reviewing the matter, a US department determined that to improve protection of infant using infant formula product, greater regulatory control over the formulation and production of infant formula was needed, including modification of industry and the FDA's recall procedures. The FDA adopted regulations implementing the Act, including regulations on recall procedures, quality control procedures, labeling, and nutrient requirements. The Infant Formula Act was designed to ensure the safety and nutrition of infant formulas, including minimum and maximum levels of specified nutrients. One of the most specific and detailed acts over the Act gives the FDA authority to regulate the labeling of infant formula and to establish quality control rules and regulations governing formula manufacturing. The Act establishes minimum nutrient requirements, defines adulteration, provides for establishing nutrient and quality control procedures, prescribes recall procedures, and specific inspection requirement. It addresses three related requirements for the manufacturer of the formula: notify the FDA before processing an infant formula, notify the FDA after a change in formulation or processing, and meeting testing requirement based on regulation with regard to major and minor changes in the formula. In 1985, the Act was revised to include minimum concentration of 29 nutrients and maximum concentration of 9 nutrients in infant formula. The FDA requested more explicit guidelines for assessing safety of new ingredients added to infant formula. A key limitation of the current approach is the lack of explicit guidelines to help formula manufacturers and their outside expert reviews determine what safety data are needed on a proposed ingredient and how they should be gathered. US Department recognized infant formula as a special category of food because there is no margin for error in ensuring the healthy growth and development of infants, requires more regulation than other types of food. Regulation of infant formulas involves both general safety provision of the Act and additional requirement specific to infant formulas. For most of the requirements specific to infant formula, manufacturers must provide assurance that the requirements have been met for each new product prior to marketing. Some foods can cause severe illness and, in extreme cases, a life-threatening allergic reactions. Approximately 1.5% of adults and up to 6% of children Under the age of 3, about 4 million people have a true food allergy. An estimated 150 individuals die each year from severe allergic reactions to food. It is critical for people with food allergies to identify them and avoid foods that cause allergic reactions. In children, milk, egg, peanuts, wheat, and tree nuts, for example, walnuts, account for 90% of food allergy reactions. In adults, peanuts, fish, and shellfish accounts for 90% of allergic reactions. Proteins have been identified as major allergens in foods. These include casein and whey in cow's milk, overmicoid in egg whites, and tropomycin in shellfish. The only way to treat a food allergy is to avoid the triggering food. Diligent label reading does not suffice. Allergy alerts on packaging are purely voluntary and are not required by law. If a food allergen such as peanut is not cited in an ingredient list, or if there is no food allergy alert printed on the packaging, many food allergic people mistakenly assume the food is safe to eat. Even if a company uses allergy alert, it is difficult to be absolutely certain that their employees will always observe the safety precautions put in place. Since 2000, the FDA has presented information on food allergies at over a dozen public meetings. It is working with food manufacturer and consumer groups to increase consumer awareness about the seriousness of food allergies and to ensure proper labeling. The National Food Products Association has called for a voluntary listing on labels of the 8 most common food allergens in plain language. For example, using the word milk in addition to the word caseinate, whereas the FDA requires food processors to label foods with all ingredients. There are gaps due to the practices such as shared manufacturing equipment. The Food Allergens Labeling and Consumer Protection Act of 2004, enacted in 2006, mandates labeling of the top 8 allergens in plain language rather than relegating it to voluntary corporation. What is the Food Safety and Inspection Service? Food Safety and Inspection Service is the public health agency with the USDA. What is the responsibility of this agency? The responsibility is for ensuring that the nation's commercial supply of meat, poultry, and end products is safe, wholesome, and correctly labeled and packaged. This responsibility encompasses the commercial supply of meat, poultry, and egg products in interstate commerce, as well as products imported from other countries. The Food Safety and Inspection Service relies on state-of-the-art, comprehensive, science-based initiatives to understand, predict, and prevent microbiological contamination of meat, poultry, egg, thereby improving the health outcomes for all the individuals. Does for disease control and prevention's role in the area of food safety includes investigating outbreaks and establishing both short-term control measures and long-term improvements to prevent similar outbreaks in the future. Central Centers for Disease Control and Prevention works with state and local health departments to investigate foodborne outbreaks and make information available to the public. Outbreak data maintained by the CDC are derived from Foodborne Diseases Active Surveillance Network. Environment Protection Agency. Laboratory studies shows that pesticides can cause health problems such as birth defects, nerve damage, cancers and other effects that might develop over a long period of time. These effects depend on the pesticide's toxicity and how much of it is consumed. Some pesticides also pose unique health risks to children. For these reasons, Environmental Protection Agency is cooperated with the individual states, regulates pesticides to ensure that their use does not pose unreasonable risk to infant, children, adults, or the environment. Environmental Protection Agency regulates pesticides under two major federal statutes: the Federal Insecticide, Fungicide and Rodenticide Act of 1947 authorized to EPA to register pesticide for the use in the United States and prescribe labeling and other regulatory requirements to prevent unreasonable adverse effect on health or the environment. It mandates a single health-based standard for all the pesticides in all foods, provides special protection for infants and children, expedites approval of safer pesticides, creates incentives for the development and maintenance of effective crop protection tools for the farmers, and requires periodic re-evaluation of pesticide registration and tolerance to ensure that the data supporting the pesticide registration will remain current in the future. What is the Food Code? Food Code is a reference document for regulatory agencies responsible for overseeing food safety in retail outlets such as restaurants and grocery stores, and institutions such as nursing homes and child care centers. It is neither federal law nor federal regulation, and is not preemptive but may be adopted and used by the agencies at all levels of government that have responsibility for managing food safety risk at retail. The Food Code is a model for safeguarding public health and ensuring food is under unadulterated and honestly presented when offered to the consumer. It represents advice for a uniform system of provisions that address the safety and protection of food offered at retail and in food service. This model is made available for adoption within local, state, and federal governmental jurisdiction for administration by the various departments, agencies, bureaus, divisions, and other units within each jurisdiction that have been delegated compliances, responsibilities for food services, retail food stores. The Food Code is available online in both HTML and PDF versions, and may also be purchased in a printed version or on CD-ROM through the National Technical Information Service in the Technology Administration. For many years, analyst in the Government Accountability Office, has questioned the organizational efficiency and jurisdictional responsibilities of the current food regulatory structure. It is their unequivocal position that enhancing the safety of the nation's food supply will remain spotty until the department and the other agencies that share this responsibility are brought together in a single food safety focus. Under the current system, meat and poultry production receives continuous inspection, whereas shellfish, fish, produces and other foods are inspected sporadically, and most food that is recalled is never recovered. Many industry sectors must respond to multiple, often conflicting requirements. The GAO has recommended that the several different federal agencies currently responsible for food safety be consolidated into a single entity. Bills introduced into the 1/7 conference would have placed the FSIS, the Center for Food Safety and Applied Nutrition, the Center for Veterinary Medicine, and the Department of Commerce National Marine Fisheries Service into a single independent food safety agency. GAO suggested that department consider enacting a comprehensive, uniform and risk-based food safety legislation and establish a single food safety agency. If does not opt for an entire organization, that it consider modifying existing laws to designate a lead agency for food safety inspection matters. Those who support the status quo maintain that centralizing the responsibility of food safety would not necessarily result in reduced cost or a safer food supply. The epidemiology of foodborne illness is changing. During the 20th century, substantial progress was made in preventing typhoid fever, now almost completely eradicated by the disinfection of drinking water, milk pasteurization, and shellfish bed sanitation. Since the mid 1970s, more than a dozen microorganisms have been newly identified as human pathogens associated with foodborne transmission. There are many factors contributing to the emergence of foodborne diseases are complex and not entirely understood. They include changes in human demographic, food consumption, industry and technology, travel and commerce, microbial adaptation, economic development and land use, and the breakdown of the public health infrastructure. The proportion of the most of the world population with heightened susceptible to the foodborne diseases has increased, both due to the increased proportion of the population with the human immunodeficiency virus and to increase median age of the population. Advances in medical technology have extended the life expectancy of people with organ transplants and those who are undergoing cancer therapy, heightening their susceptibility to severe foodborne illnesses. Changes in food consumption have resulted in the identification of microbial foodborne hazards. For example, increased consumption of fresh fruits and vegetables has resulted in outbreaks associated with fresh produce, unpasteurized cider, sliced tomatoes, fresh squeezed orange juices, frozen strawberries, green onions, raspberries, and lettuce. The increase in the number of meals eaten away from home has increased exposure to outbreaks, predominantly the result of improper food handling practices. The centralization of the food industry has increased dispersion of outbreaks, which affect large number of people. International travel raises the risk of travelers returning to their motherland infected with foodborne pathogens, which may be carried home to affect non-travelers. Imported food may harbor pathogens. Antimicrobial resistant strains of Salmonella have become increasingly prominent. Other resistant pathogens have been identified as well. Manure from farm animals serves as a reservoir for Salmonella, C. jejuni, and other farm pathogens. It is becoming increasingly difficult in the world to dispose of the 1.6 billion tons of manure it generates annually. Limited budget in public health agencies have resulted in underreporting of foodborne infections. When the infrastructure of diseases surveillance is limited, recognition of the outbreak is jeopardized.